Alright, welcome. Today we're going to be talking about Precalculus Chapter 9. And if you're unaware, I am Spencer Buckley presenting this. So basically today we're going to go over everything that we discussed and went over in the Chapter 9 review and everything we were tested on in the Chapter 9 test. And I chose this because Chapter 9 was fresh on my mind, and it was a chapter that I understood, I do believe, quite well. And so, let's just go and jump right into this. So the first thing we want to talk about here is graphing pairs on a polar grid. And I personally believe this is really easy to do. There's not a lot of hard math in this. So our question we're going to be working with is x for 30 degrees. And these problems are really easy to do. Basically, you draw 4 circles because of that 4 there. And then we're going to go and draw a line going 30 degrees from the origin. And that's because we have 30 degrees there. And then basically we just graph a little point right where the 4th circle and that line meet. And that's how we graph this. So let's see how this pans out. We draw our x-plane, and then we go and draw our y-plane, and that's the basis of our graph. And now we'll graph the 4 circles. So there's circle number 1. There's circle number 2. Circle number 3. And lastly, circle number 4. These circles may be a little uneven, but that's just because PowerPoint can be difficult to use at times. And now we go and graph our angle going roughly 30 degrees from the origin. I say roughly because, again, PowerPoint can be difficult to get the exact measurements. And finally, we graph our little pink dot right where that line and that big blue circle meet. And that's just where the 4th circle and the 30 degrees meet. And that's how we graph pairs on a polar grid. Our next problem will be graphing polar equations. Again, something that I believe are really easy. In fact, I believe easier than the problem we just did. And for this, we're going to have 2 different problems. The first of which is r equals 2, and the second is x equals pi over 3. So, basically, to solve question number 1, we're going to draw a graph with 2 circles. So that's going to be really easy to do. And for the second one, we're going to draw a graph with a line at whatever the respective angle is. In this case, pi over 3 or 60 degrees. So first we draw our x-plane, and then we draw our y-plane. And for problem number 1, we're going to draw 2 circles. So circle number 1, and then circle number 2. So that's really easy to do. That's literally everything you have to do for question number 1. Really easy. And then for question number 2, we're going to draw our x-plane, and then we're going to draw our y-plane, and then we're going to draw an arrow that goes through the origin. And unlike the previous problem, this is going to go all the way through, not just from the origin and up, because that's just how we do these problems. And so that is how you graph polar equations. Our third thing we're going to talk about today is finding the distance between a pair of points. Now this one does involve using a calculator, but it's really easy to do, and all you have to do is plug it into the calculator. So, our question we're going to be working with is 4 60 degrees and 5 150 degrees. So how do we solve this? Basically, we're going to plug the numbers into the equation, and then we're done. So, what is the equation? If it will load, we will see that the equation is the square root of r1 squared plus r2 squared minus 2 times r1 times r2 times the cosine of angle 2 minus angle 1. And it kind of seems like a lot. Once you really look at it, it's not that bad. 4 is going to be our r1, 5 is going to be our r2, 60 is angle 1, and 150 is angle 2. So we just plug that in, and so that gives us the equation of the square root of 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of 150 minus 60. And when you plug that into the calculator and hit enter, you will get that the answer is 20, which worked out wonderfully considering I just happened to pick random numbers and it fortunately ended up being a whole number. So, what's the next thing we're going to talk about? Next, we're going to talk about finding pairs of two polar coordinates for each point, given rectangular coordinates between 0 and 2 pi. Now I know that sounds like a lot, but again, this is something that's not really too complicated once you take a look at it. So, if we look at our question is 4, 9. And what we're going to do, how we're going to solve this problem is we're going to graph a point at 4, 9. And then we're going to make a triangle from the origin that uses that point. And all we need to do after that is to find the hypotenuse using the Pythagorean theorem, and we're going to use arctangent to find what the angle of the triangle is from the origin. And then our second point will be found by subtracting said number from 360 or 180. So, let's start this problem by graphing our x-plane, and then we'll graph our y-plane. And now we'll go and create a triangle that moves 4 to the right and 9 up. So, that's our triangle. That shows us that it's 4 to the right, and that 9 shows us that it is 9 up. So the first thing we're going to do is type in second tangent into our calculators, and then type 9 over 4, and that will give us the angle of 66 degrees. And then after that, we need to find what the hypotenuse is by using the Pythagorean theorem, which, if you don't remember, is a squared plus b squared equals c squared. Or in this case, 9 squared plus 4 squared equals the square root of 65. Or in this case, it would equal 65, and then we find the square root of that. And unfortunately, I realized when making this that I forgot to change the answers. So it says that the answers are the square root of 65 and 67 degrees, but that's supposed to say 66 degrees. And then the second answer, after we go and subtract 66 from 360, it will give us the answer of the square root of 65 and then 294 degrees. So really simple to do, really easy actually. You just plug a couple things in your calculator and do a little graphing, and then you have your answer. So what's next? Next, we're going to be finding rectangular coordinates. Again, a little bit of graphing, a little bit of calculator, and for all of these, I would highly recommend having that graphing circle we made a note card of earlier, as it will be extremely useful and pretty much necessary. So, our problem is x, 3, and 45 degrees. And to solve this problem, we're going to graph 3 circles, because there's a 3, and we're going to make a 45-degree angle from the origin. And then we're going to make the hypotenuse 3, because of the 3 circles. And then we will need to find the missing sides, which is going to be easy for things like a 45-45-90 triangle and a 30-60-90 triangle. And the reason that's easy is because basically it means that we have a set proportion and ratio for what those sides are. And in this case, we're lucky to have a 45-degree, 90-degree triangle. We're lucky because I chose it. So, circle number 1, circle number 2, and lastly, circle number 3. Now we will draw our 45-degree angle. We're going to turn that into a triangle, and we're going to show that that is 45 degrees with a hypotenuse of 3. Now I said earlier that each triangle has a ratio or proportion that goes with it, and if you should have written this down on your note card with the circle, but if you didn't, basically for a 45-45-90 triangle, where the hypotenuse is x square root of 2 and the other two sides are just x. So to solve this problem, we simply need to divide 3 by the square root of 2 and then simplify, or rationalize actually. And that will give us 3 square root of 2 over 2 for both sides. And that's how we solve this problem. It can be a little confusing without seeing it, so that's why I wanted to go and really show you how this problem is done. And if you know what the triangle ratios are and the proportions are, these problems are going to be really simple and really easy to do. So, that's all I have for this video. Here's the bibliography that simply says what my sources were. I have the 3 sources that were required. I used, for the first one, a website that just talked about what rectangular coordinates are, and I just used that to go and refresh my memory and to go and get a deeper understanding. I have the book that we've been using all year because I figured that was a really good source to have. And then we have this other source that's another website, and that talks about polar equations and their graphs. And again, I just used that to go and refresh my memory and to use it to get a deeper understanding of what I was speaking about. And that is the end of my presentation. Again, this is about Chapter 9. This is everything that was on the Chapter 9 review, and at least one problem for each different type of problem on the Chapter 9 review. And it has a demonstration of one demonstration of each type of problem that was on the Chapter 9 test.